We have understood like how to plot the histogram when the unequal class size is given. So in that case we have seen that we need to find out the adjusted frequency. Now we'll see the next case in which we'll get the data in the form of midpoints. Like we take one example like in this type midpoints of class intervals are given. So this is the third type of data we can get, midpoints of class intervals. That is, instead of class interval, midpoints are given. Let's take one example, like suppose if I say, let's say class interval, instead of class interval we use midpoints here. Midpoints here, like suppose if I take midpoints as 5, 15, 25, 35, and on the basis of that I have taken the let's say some frequency 4, 3, 2, 1. So now as you can see that midpoints are given against frequency. In this case we will not be able to plot the histogram, because we know that histogram can only be plotted when the class intervals are given or the continuous frequency distribution data is given. Continuous data is given. So if the data is not continuous or class intervals are not there, we cannot plot the histogram. So in this case what we need to do, we need to convert these midpoints into class intervals. So as we know that these midpoints are of the class intervals. Like suppose if I take the class as 0 to 10, what will be the midpoint in that case? Midpoint in that case will be 5. That is 0 plus 10 divided by 2. That is 5. 5 is the midpoint. So as we know that midpoints are given, so it is we have to do or we have to convert this midpoint into class intervals. So how to do it is, what we can do is suppose like it is given here that first midpoint is 5, second is 15. Difference between these two midpoints are, or these two consecutive midpoints are 10. What we can do is, like first we have taken the difference between the consecutive midpoints. So difference between consecutive midpoints. So that suppose we have taken. So here like first two midpoints we can take. So in that case difference is 10. Now in the second case what we need to do is we divide this difference by 2. So divide difference by 2. So that will get is 10 divided by 2, that is 5. Now in the next step what we need to do is we need to add and subtract the result from the midpoints. So add and subtract this result, that is 5, from midpoint. It means for finding out the class intervals, what we need to do is, for finding out the lower limit, what we need to do is we need to subtract this result from the midpoint, and for finding out the upper limit, what we need to do, we need to add this result from the midpoint. That is, if we need to find out the lower limit of any class interval or of any midpoints given here, what we need to do is we need to subtract 5 from the midpoint. So what we need to do, midpoint minus 5. So in this way we get the lower limit, and for finding out the upper limit, what we need to do, midpoint, we need to add this result to the midpoint. So we will get the upper limit. So here as you see that the midpoint is 5, so and result is also 5. So what we need to do to find out the lower limit is 5 minus 5, that is 0 will be our lower limit, and accordingly upper limit will be 5 plus 5, that is 10. So this is the class interval for the midpoint 5. Again now we need to find out the class interval for the midpoint 15. What we need to do, 15 minus 5, that is 10, and 15 plus 5, that is 20. So this is the class interval for the midpoint 15. In the same way, 20 to 30 will be the midpoint for 25, and 30 to 40 will be the 20 to 30 will be the class interval for the midpoint 25, and 30 to 40 will be the class interval for the midpoint 30. So in this way, we need to convert these midpoints into class interval. Then we will be able to plot the histogram. So now, as you can see, we have converted this midpoint into the class intervals, and against the frequency is given. So it is easier for us now to plot the histogram, because now the data is actually in the form of frequency distribution table or continuous frequency distribution table with equal class interval. So we'll be able to plot the histogram accordingly. So now we'll see one example based on this. First, we write down the midpoints. Accordingly, frequency is given on the basis of that midpoints. So midpoints and number of students. So what we have taken midpoints and the number of students. So accordingly, now we'll plot it. So midpoints here given as 150, 160, 170, 180, 190 and 200. Accordingly, number of students are given as 8, 10, 25, 12, 7, 3. So now what we'll do is, we'll convert this midpoints into the class intervals, and for doing this, what we'll do is we'll follow the steps that we have written earlier. So what we have to do, we have to find out the class intervals for the midpoints. So midpoints is given as 150. So what will be the class interval for this midpoint 150? So now, as you can see, there is a difference between two consecutive midpoints. That is, if we take the first two midpoints, difference between those midpoints is 10. And so first step is to find out the difference. So we have find out the difference, that is 10. Next step is we divide this by 2. So if we divide this by 2, what we'll get? We'll get as 5. And then the third step will be, for finding out the lower limit, we need to subtract this 5 from the midpoint. For the upper limit, we need to add this 5. So if we subtract 5 from 150, what we get is 145, and accordingly the upper limit will be 155. Now the same case for 160, subtract 5, so we will get 155, and accordingly our upper limit will be 165. Now in the same way, here also class interval will be 165 from 175. Here it will be from 175 to 185. Here it will be from 185 to 195, and here it will be from 195 to 205. So in this way, we have converted this into class interval, and now it is easier for us to plot the histogram on the basis of this data. So we'll take this class interval on the x-axis, and the number of students or frequency will be taken on the y-axis. And now definitely we'll plot the graph for the class interval and the number of students. We'll not consider midpoints here, because we have converted those midpoints into class intervals. So in this way, we need to do some modifications here when the midpoints of class intervals are given. And now we'll see one more case in which class intervals are given in inclusive form. Class intervals are given in inclusive form. So class interval in inclusive form is, as we have already studied, what is inclusive form. So inclusive form means, like suppose we have taken one example also of inclusive form, like in this inclusive form the class intervals are given like 1 to 10, 11 to 20, 21 to 30. That means that the upper limit of the previous class is not equal to the lower limit of the next class. This is the inclusive form. So in the inclusive form also we cannot plot the histogram because again it is not continuous. There is a gap. Like if we take the class interval as 1 to 10, then 11 to 20, then 21 to 30, and then 31 to 40. So again this data is not continuous because continuous means, proper continuous means that the upper limit of this class will be equal to the lower limit of the next class, and this is not the case here. So we need to convert this data, or we need to convert this class intervals into the proper continuous form or the exclusive form, so we will be able to plot the histogram accordingly. So what we need to do is, suppose if the data is given in this form, what we need to do, we again have to follow some steps. Like first step will be, we need to find out the for converting into the exclusive form, what we need to do, we need to make the upper limit of the previous class will be equal to the lower limit of the next class. Then the data will be in the exclusive form. It means if 10 is here and 11 is here, then it is not continuous. So accordingly we have to make this 10 and 11 the same number, or we need to convert this into the same number to get the data into the exclusive form. And what we need to do, first step will be, we need to find out the difference between these two numbers, because we have to make these two numbers equal. So we need to make both these numbers same. So difference we need to find out, difference between the upper limit of next class minus lower limit of previous class. So that will be equal to 11 minus 10, that is 1. So this is the difference. Now what we need to do, we need to divide this result by 2. So we'll get as 1 by 2 or 0.5. And now the third step will be, again what we need to do, for that the result we got as 0.5, we need to subtract this result from the lower limit, and we need to add this result to the upper limit. So upper limit and lower limit of each class. So if we take the first class as 1 to 10, so in that case what we need to do for finding out the lower limit, what we need to do, we need to subtract this 0.5 from the current lower limit. So accordingly we will get the new lower limit, and in the upper limit what we need to do, we need to add the 0.5 to the upper limit. So accordingly we will get the new upper limit. So in this way our class intervals will become like 1 minus 0.5, it will from 0.5 to 10 plus 0.5, that is 10.5. This will be our first class. Next class will be, now again in the second class what we need to do, we need to subtract this 0.5 from the lower limit, that is 11 minus 0.5, that is 10.5, and the upper limit will be 20.5. Then the third class will be 20.5 to 30.5, and the fourth will be 30.5 to 40.5. So in this way we have converted this into the proper or the you can say the exclusive form or the continuous frequency distribution table, and now it is easier for us to plot the graph for this class intervals corresponds to the frequency, because now it is in the proper continuous form, that is continuous frequency distribution table with equal class size and in the exclusive form. So now we will see one example based on this. So first we will write down the class intervals and the frequency that are given. Like suppose if we will take here age group, and we will take number of females. Like suppose if we take age group as, let's say, 10 to 14, 15 to 19, 20 to 24, 25 to 29, and 30 to 34. And now accordingly you take the number of females between 10 to 14 it is 300, 15 to 19 it is 980, 20 to 24 it's 800, then it's 580, and then is 290. Now what we need to do, as you have seen here, that is data is in the inclusive form. So we need to convert it into the class intervals into the exclusive form. Now again what we need to do, as you know, for converting into the exclusive form, we need to make the upper limit of the previous class will be equal to the lower limit of the next class. So it means we need to make 10, 14, 15 to the same number. And for doing it, what we need to do, first step will be we'll take the difference between these two numbers. Difference is again 1. We'll divide this 1 by 2. This is our second step. So we'll get again 0.5, and now we need to subtract the 0.5 into the lower limit, and we need to add 0.5 to the upper limit. So if we subtract 0.5 to 10, we'll get 9.5, and if we add 0.5 to 14, we'll get 14.5. Now again same procedure in the next step or next class interval, that is and accordingly we get the class interval as 14.5 to 19.5, then 19.5 to 24.5, then 24.5 to 29.5, and then 29.5 to 34.5. So accordingly we get this class interval in the exclusive form, and now we can easily plot this class interval and the number of females in the form of histogram. So this class interval again will be on x-axis and number of females will be on y-axis. So now it is easier for us to plot the histogram. So in this way, this type of modifications are required whenever the different data is given. That is, whenever data is not in the proper continuous frequency form, or you can say when the data is not with the equal class size, then we have to do this type of modifications. So these cases we have seen. Now we move on to the next part, that is, as we have seen that how to plot the histogram. Now the third type of graphical representation is frequency polygon curve. So third type of graphical representation is frequency polygon curve. So how to plot the frequency polygon curve? First thing is, frequency polygon curve can be plotted by using histogram, and it can be plotted without using histogram. So there are two ways for plotting the frequency polygon curve, that is by using histogram, and second is without using histogram. So in the by using histogram means we need to make the histogram also, and again on the basis of that histogram we need to plot the frequency polygon curve. And without using histogram means we do not have to make the histogram, you only have to make the frequency polygon curve. So definitely it will be mentioned in the question, like which type of frequency polygon curve you need to make, that is with histogram or without histogram. So accordingly we need to make that type of frequency polygon curve. So first we will see frequency polygon curve by using histogram. So by using histogram means we need to first make the histogram, then accordingly we make the frequency polygon curve. So how to do it is, we'll directly take one example is, let's take one example as, suppose marks are given of students, and accordingly number of students are given. Let's say marks are between, let's say 600 to 640 to 680, 680 to 720, and let's say 720 to 760. These are the marks given, and accordingly number of students are given. Let's say 16, 45, 156, 284. So accordingly, these are number of students given between these marks. So now, as we know that it is by using histogram. So first we'll make the histogram. Then we'll see how to make the frequency polygon curve. So now again we'll plot this data. So x-axis and accordingly y-axis. This is our origin. So marks. So definitely marks will be on x-axis. So as marks are on x-axis, so accordingly plot the marks here on. So as the marks are starting from 600, so definitely we start from 600. And as we are starting from 600 directly from 0, so definitely we will make the king here, which indicates that we are not starting from 0. So that's why we are making king here. So 600 to 640, 640 to 680, 680 to 720, and 720 to 760. These are the marks we have represented. And now we have to represent the number of students. Number of students on the y-axis. So how to do it? As we can see this data. This data is so accordingly we will take the points here. What we can do, like as you can see here, data given here is very much different. So we'll take the closer values, or we'll take the near about values here. So we'll make this modification here. Let's take some value near about some values of near values of 16 to 40. Suppose we take that values. Let's take it as here as 62, and let's take it here as 27. So now it is easier for us to plot here. Otherwise, the graph will be very high. So what we do is we'll take points accordingly. So let's take it as here 10, 20, 30, 40, 50, and 60. So 60, if we take to 60 also it is sufficient. Also we can take up to 70 also. So for 600 to 640, number of students are 16. So it will definitely between 10 to 20. So we will accordingly plot the histogram. So we have taken for 600 to 640. Now for 640 to 680, what we need to do? We have taken this for 640 to 680, 680 to 720 we need to take. And now we'll take for 720 to 760. So in this way we have made the histogram. Now for making the frequency polygon curve, what we need to do is we need to take the midpoints of these marks. That is, as you can see, the midpoint of 600, that is 600 for 640. Midpoint is 620. That is 600 plus 640 divided by 2. That is, we get as 620. So for 620, the number of students will be same, and we'll take this point here on the histogram, or on the top of this bar of the histogram, and we'll do the same procedure to the every bar of this histogram. Now for 640 to 680, midpoint will be 660. So again we'll mark 660 here. And again the number of students will be same here. Now for 680 to 720, we'll take again the midpoint for 680 to 720, it is 700. So again we'll mark 700 here. And for 720 to 760, it is 740. So we'll mark 740 here. That is, we need to mark the midpoints of the marks that we have taken on the top of the bars of the histogram. And now we accordingly will join these midpoints with the line. So in this way we have made this curve. But this curve is still not completed, because we are talking about frequency polygon curve. Polygon means that it should be this curve should be a closed figure. So for making it as a closed figure, what we need to do, we'll take one class interval above, or one class interval before the first class interval, and one class interval after the last class interval. It means that is before 600 to 640, the class interval should be 560 to 600, and for that the midpoint will be 580. As midpoint is 580, so what we need to do is, and the number of students in that case is 0, because there are no number of students given for 560 to 600, so we'll take it as 0, and midpoint is 580. So what we'll do is, we'll take the midpoint here, or that is for 560 to 600, we'll take the midpoint 580 here on the x-axis, because number of students are 0, and then we'll join this midpoint to the x-axis, and again the same procedure we'll do for making the graph complete, or for closing the graph. That is we'll take the next class interval of the last class interval, that is 760 to 800. We'll take the class interval, midpoint is 780, so we'll mark 780 on the x-axis, because again the number of students are 0 here, and again we'll join this last point to 780. So this curve that we have made by using line is known as the frequency polygon curve. So in this way we need to make the frequency polygon curve, that is we need to take the midpoints of the class intervals, and all those midpoints that we have taken will be plotted against the number of students, and then we need to join all those points to make the frequency polygon curve. And for completing the frequency polygon curve, we need to connect this frequency polygon curve to the x-axis on the both sides, that is from the starting point and also the end point. That is, starting point and end point of this frequency polygon curve will be from the x-axis. Then only this frequency polygon curve will complete it. So now, as you can see, this frequency polygon curve is completed. So in this way we need to make the frequency polygon curve by using histogram.